All right, so thank you everyone for joining us this evening. It is 7 o'clock. If anyone else joins us, I will go ahead and admit them to this presentation. What I'd like to do first is introduce or have our student panel and our faculty introduce themselves. They are the ones, there's an owl in the room. So what that does, it's a video camera that kind of moves around to whoever's speaking. So they will go ahead and introduce themselves, and then you can go ahead and ask questions after that. Take it away.
Start with me. Hi, I'm Jordan Fox. I'm a PhD student here at Rolla, Missouri for nuclear engineering and radiation science. My specialization is in nuclear medicine, specifically electron beam optics for a prototype X-ray tube. And then a quick little fun fact is I have a second-degree black belt in Taekwondo, and I used to swing dance.
All right, hi everyone. My name is Nari Loftus. I'm a senior here in the nurse department. I'll be staying here an extra year though to complete my master's degree after I graduate with my bachelor's in May. Myself, I'm from California, and the fun fact is I have a dual citizenship.
All right, my name is Kelsey Tressler. I'm a junior in the nuclear department. Fun fact about me, I like to crochet.
All right, let's see, my name's Eli Poland. I'm from Kansas City, Missouri. I'm currently a PhD student like Jordan is here in the nuclear engineering department. And a fun fact about me is I've moved 5 times in the past 4 years.
Ouch. My name is Joshua Schlegel. I'm one of the faculty in our program. I teach our heat transfer and fluid mechanics courses for nuclear reactors. Apparently Dell is responding a little slowly. It's not coming over to look at me yet, but fun fact about me is I like to go camping and canoe trips and stuff like that. So.
And if it swings my way, there it goes. Hi, I'm Joe Newkirk. I'm actually the department chair of nuclear engineering and a faculty member here. My research is in nuclear materials, and my fun fact, I'm a licensed pilot.
Okay, so very interesting. Thank you everybody for introducing yourselves. A couple of questions, if you wouldn't mind talking about what campus life is like for students, with the student experiences, like if you wouldn't mind talking about class sizes and different classes, anything interesting that you've learned in your first and maybe in your freshman year, if you can think back that far for all you PhD students. That I think that would help give the students a little bit of insight as to what to expect.
You remember
I'll go first. I didn't have a freshman year either. I transferred in, right? So I transferred in from a community college in my junior year, credit-wise, to this university and this program, and kind of just seamlessly jumped into nuclear engineering. I had done some general engineering stuff, and my experience with kind of just being dropped in the middle of nuclear engineering is that it was okay. Definitely challenging trying to catch up. You know, I didn't have the freshman and sophomore classes that some of my classmates did to, you know, build that knowledge base, but the professors did a really good job of not only knowing who I was before I even saw them, but they knew I was a transfer student, and they knew that I didn't have that background, and they made it really easy for me to kind of acclimate to that mindset needed for nuclear engineering. Like I walk in, I knew the basics of like alpha, beta, gamma, and then I get dropped into reactor physics and they say, have fun. And I actually did. I had a pretty good time learning everything that I did in my undergrad.
I guess we're going down the line now. So I think I can speak a lot more on like the student experience. I myself got involved on campus in quite a lot of ways. Currently, well, last semester I had 5 different executive positions in 5 different organizations on campus, including Greek life and professional societies and honor societies, volunteer groups, things like that. So even in such a challenging program like at S&T, I had free time for myself to find things I enjoyed, to make friends, network with people, just keep busy, and I've really enjoyed that. But I think the biggest thing that I learned, like speaking on like class sizes, I think the biggest class I ever had was just one of my first gen eds was like chemistry. I think I had 70 people in that lecture hall, but they put us in the theater. It was huge. Like, no, in strike halls. I'm thinking, I'm getting messed up a little bit with COVID because things had to change around with the room. But in strength, I think that was my biggest class size, but there was always one-on-one instructing in like labs and like maximum 20 students to a professor and a TA. So I never felt like I was really lost for help. And the biggest thing that I learned like my freshman year was that the professors all, even in other departments, want to help me out and will answer questions. And as long as I show up willing to learn, that they will share their knowledge with me.
I'll say the student experience at S&T is what you make of it. You can choose to hold up in your dorm room and never see anyone or talk. And you will probably not do well in your classes if you do that, because it's a team effort at S&T. You gotta make friends and you gotta make a study group. The nuclear department has a lot of opportunities for different groups to get involved in. And professors here genuinely want you to succeed. If you talk to them, they will give you the resources. Like I said, it's not easy to get an A in S&T, but there's not an excuse to flunk out, because you have professors that want to help you, that want to be there for you and to succeed to your maximum potential.
Dealt with. Nice.
All right, I guess, to add to that, average class size is like 25 to 30 generally throughout like my whole undergrad. It was about that. Grad classes are much smaller. They're normally around 10 people in a class. That said, like even during undergrad, your professors always have office hours. They're always available by email. They're always easy to contact. You know, never had any issue. If I ever had a problem with homework or, you know, if I'm studying for an exam and I had a question on some lecture or something, never had any trouble being able to ask a professor for help or anything. And other than that, yeah, just like what Kelsey said, you can just be stuck in a dorm room and you won't have a lot of fun. But if you get out and go join some organizations, you'll have a lot better of a time here.
And there are a lot of organizations here on campus and with a lot of different interests. I mean, the Spelunking Club is out
Part of
there.
that, I've been.
You know, there's an explosives engineering program. We actually have a few students who are doing minors in explosives engineering. And some of the faculty in that program are licensed for fireworks. They manufacture and put on fireworks shows and stuff like that. You're in charge of the blacksmithing club, right?
Advisor to the blacksmithing
So-
club, whose sword won the grand prize of the national competition.
And then with
glass blowing club as well, and other things that you get involved with, pottery
And-
classes.
just within nuclear engineering, American Nuclear Society and Women in Nuclear, which men can also join. We have some representatives from Women in Nuclear here as well, and you're in charge of ANS, right? President of ANS, so. And there's an ANS student conference in the spring every year, and we usually send a fairly large contingent, and they get to meet nuclear engineers from all over the country. So there's a lot of other really interesting things to get involved in.
We had the largest student section attend last year.
Yes.
Okay, I'll go ahead and ask another question. Any students or future students that are joining us this evening, if you have any questions, if you want to raise your hand in the chat or just go ahead and ask the questions, if there's a slow point or if you want to put your question in the chat, please feel free to do so and I will bring that up to the panel. Another question that I'd like to ask is, are there any scholarship opportunities outside the university available for nuclear engineering?
I can start off with that. American Nuclear Society provides scholarships for nuclear engineering students across the country in varying amounts, starting as early as your freshman year. So I think the smallest ones are $500. The most common numbers are between $2,000 and $2,500. Yes, American Nuclear Society, sorry about that. There's also scholarship opportunities available from Department of Energy, although those are typically restricted to upperclassmen. That's through the Nuclear Energy University programs. Those are the major ones, but there's also a lot of other smaller ones. Nuclear Fuel Commission is done through us, so that's a departmental scholarship, but those are also restricted to upperclassmen.
Does GAN do undergrad? Or is that only
No.
undergrad?
No,
Okay. Of course, there's the Navy has several programs.
Oh, yes.
We typically have a student or two involved with and go on to a
the
career in the Navy.
the nuclear propulsion officer candidate is our big one, but that starts your sophomore year. And
And the nuclear propulsion can start before you come, like a freshman year.
maybe, yeah, I'd have to look into that.
For the new block, you have to have physics,
Yeah,
calculus, and a chem class, I think.
So you might be
Yeah.
able to transfer in with it. if
Yeah,
you're-
yeah.
That's the new part. There's
Yeah.
There's another
doesn't make you be an officer.
Yeah,
Honestly, since we're talking about NUPOC anyway, the benefits of going to NUPOC compared to like Army ROTC, the strictness of it is pretty relaxed, right? Like, there's no parade march.
they have twice yearly physical fitness checks up in St. Louis, but
Yeah.
aside from that.
Yeah, that's like the
that's
only
it.
thing you have to do. Otherwise, they just want you to focus on your classes. And there is a GPA requirement depending on like which one of the 4 tracks you go into. Ranging between, I think, like a 3.5 up to a 4.
Yeah.
You don't have to worry about like, waking up early mornings, being in uniform to do a parade march. You don't have to worry about flag ceremonies.
Yeah.
You just do the 2 physical assessments a year and you can focus entirely on your studies and they pay you for it. They'll cover your tuition and your fees and then they give you a stipend to live off of. I had a couple of good friends in my undergrad who did that and they had a great time with it. They got to basically do what they wanted and they passed their classes with flying colors.
We usually have 2 or 3 students a year join that program, and I think we're one of the most prolific universities for the Navy as well.
I want to hop in real fast. So some of those American Nuclear Society scholarships are available for seniors in high school to apply to now. And they're due February 1st. So many of you who, if you do know that you're going to be studying nuclear engineering this fall, do look into those. You do have a few more weeks to maybe get another extra $1,000 that'll help toward your tuition.
Every little bit helps.
Oh, yeah.
Don't be stingy about the $500 scholarships. Those add
They
up.
add,
Help.
yeah.
Go for them.
Summer camp. We waive credit still?
So we do have a nuclear engineering summer camp. When is the application gonna open? In the next couple weeks here?
I think so.
So you can actually check out our webpage in the next couple of weeks. The applications for that will be open. If you come here for the summer camp, we waive 1 credit from your plan of study your freshman year. It's our introductory nuclear engineering class, 1105. And so the summer camp essentially covers a lot of the stuff that we would talk about in that class, so we waive that for you. So it helps lighten your credit load that first semester a little bit.
There is a cost to attending the summer camp, but the fee waiver on that class is worth more than the cost of the summer camp. So you're coming at that, right?
Not quite,
Not quite?
no.
Has that changed?
The fee waiver is only worth about $400.
Oh, okay. We did change that.
Yeah. It's
My
only
bad,
one
ignore
credit.
me.
And
That's okay. It's
if
just a
you
little bit
come
older.
here, there's
information.
also summer opportunities to
Yes.
earn money, and internships and co-op positions, and a lot of students can go away. If you'd like to, spend the summer out in Idaho or New Mexico or something, you can go to a national lab, there's companies, and so you can earn money during the summer learning.
Okay. Thank you for pulling the chat up. Yeah.
Yeah.
I know I saw a question.
Donna, do you want us to answer the question in the chat or?
I'll go ahead and ask it. Let's see. So Tyler's asking what classes outside of the gen ed classes do you find that students struggle with the most in this department?
Oh, in the department. Okay, I was thinking outside. of the department.
So- Nuclear engineering classes, or would you also think like math and physics as part of that, since those aren't really gen ed?
They are. Up until Cal 2 is better every.
Just like here, you consider, well,
It's basic math and science, not general education.
Jen,
I guess those Nukies.
I guess I will.
So
you're thinking engineering.
before we get back to Tyler, are you asking about just nuclear engineering classes or about math and physics as well? Okay.
Honestly,
It's a junior year, Kelsey. How you doing?
Teachers here want you to succeed and they create their courses to help you. I've gotten an A on all my NUPE classes, and honestly, my NUPE classes have never been the ones where I'm like sweating over. Like the professors all know me by name, Like,
I think the first one that's really a head jog though is
Fluid
fluid
mechanics.
mechanics with Dr.
Yeah,
I was gonna say.
There's so much support, like this is a beautiful
Yeah.
structured class, like
it's
the first time you're learning your engineering.
it's structurally different than you would expect from other
Yes.
courses, so you just have to learn it. So after that first module, it's, as long as you can keep up with the work, which it's not that hard to do, you'll be fine.
yeah, really, in my experience, having watched a bunch of other students go through the whole program. I came in and I really struggled in fluid dynamics. But that was also one of the first times Dr. Schlegel had taught it. And it has
Yes.
vastly improved every year since. Dr. Schlegel does a great job of improving his course material, both for fluid and heat transfer. The other class that some people have problems wrapping their head around, reactor physics. But that's just because you kind of just gotta dive into it, and you're trying to wrap a new way of thinking around fluid dynamics while also wrapping your head around reactor physics. So it's a rigorous coursework, but they're both doable, and the resources are here in the department to accomplish that. Whether it's the professors, whether you go find a study group amongst your peers, or you go find a grad student. It wouldn't be the first time if somebody came up to me and asked for help with reactor physics or something and asked me to walk them through a problem or point them in the right direction.
The one thing I'll say is, I've never seen somebody who got their reactor operator's license struggle with reactor physics. So we have a wonderful facility on campus called the MSTR, the Missouri S&T Reactor. So I went through that operator program. I have my license to operate the reactor from the NRC. And when I was going through that program, I learned all of the components of that class a year and a half in advance of me taking it. So conceptually, I had those problems down. So being able to go to a physical facility and actually see the kind of things you're learning really, really helps. Nuclear is one of those things that's hard to get a visualization of, but we're really lucky that we do have a facility that allows us to see some things.
To also add on to the reactor physics part, Dr. Alajo, one of our professors here, teaches nuclear fundamentals. And that's kind of like a lead into reactor physics. So like as long as you're paying attention in your classes and you're just like going through it, like you don't have to get a perfect A, but if you're like actually giving it the college try and doing well, you should have a seamless time. We say these are the most difficult courses, but it's pretty rare that I would say a student really struggles through them.
I think one of the biggest challenges, especially about that first semester junior year, is the course load, because it's our highest credit hours for that semester, according to the plan of study. Not everybody's exactly on the plan of study. But your junior year, you have 2 18 credit hour semesters planned, and that's just to keep all the courses sort of where they need to be. And that's, I think, a big part of the challenge for that junior level.
Get a planner.
Yeah.
A planner
Yes.
is your Bible.
And
She has
study
saved
groups.
me. Yeah.
I actually structure my classes, fluid mechanics and heat transfer, like they were talking about, with teams. So you will be in a team of 4 students to work through the class, and I've had instances where those teams have stayed through the end of the student's senior year, even though they're not in my class anymore, because they just work well together and they study well together, and so those kinds of things are things we try to promote.
Can they still vote your test to not matter?
No,
Okay, you fix that?
that was, yes.
Okay.
So I used to allow the students to some latitude to adjust the weighting in my grade book according to what they thought should be the most important thing in my class. And then I had a semester where the students took advantage of that policy, and then I had to stop doing it. So
That's for only 10% of the.
so in nuclear, I think that pretty much covered some of the challenges. I will also say that some of the initial calculus and physics courses challenge the first year students, not so much necessarily because of the content, but just because it's a very different approach than you see in high school. You only spend what, 12 to 15 hours a week in class with the professors, compared to in high school where you're there 7 hours a day, 5 days a week. And so there's a lot more freedom, which is a wonderful thing to have when you're a college freshman, but it's also a risky thing. You have to use it responsibly. So we have some other questions, and so if we want to continue moving on.
Okay, so thank you very much, Dr. Schlegel. So Calvin is asking, is a nuclear engineering, mechanical engineering double major a reasonable overlap?
Define the word
Yeah.
reasonable.
Yeah.
So it's reasonable if you're willing to commit to spending 5 or 6 years here to have that extra room in your course load to take the extra classes that would take. In terms of like relevancy, a lot of the, basic, what is it, science and
Yeah,
math?
it's approximately 3 semesters of
Yeah.
extra coursework.
I know-
About 5 semesters can be duplicated or used as electives for the other program and made to cross over, but you end up with about 3 semesters worth of additional coursework to make that happen.
As far as actually double majoring in it, Dr. Schlegel, feel free to correct me if I'm wrong on this in a second here, but personally, again, my opinion, I don't see much reason to double major in it because we, like, as a nuclear engineer, you already learn a lot what a mechanical engineer does. Nuclear engineers kind of get to be a jack of all trades, but we get to be really specialized in anything involving radiation. So even though you don't have a bachelor's in say mechanical, you can get hired on at Ford as a nuclear engineer, which
And
we
we've
had
had-
that happen.
We've had 2 students go on to have careers at Ford Motor Company. We've had another go on to design heat exchangers for a startup company up in Columbia, Missouri. So not all of our students end up going into careers in nuclear. Some of them just sort of fall into a career in another area and then that ends up where they go. So there's definitely a lot of overlap there.
Perhaps a more reasonable approach though sometimes is to minor in the other
Mhm.
discipline.
Yeah.
Rather than to get a full double major.
Honestly, as a freshman, I didn't really understand minors and they're actually really, really useful.
Yeah.
So
Yeah.
built into our program is a mathematics minor. I
Uh,
had to take, really? Is it the thermal
You
mass?
can- Well, you can get a math minor by using one of your electives as a math class, but it's not built in automatically anymore.
Oh, even for me, it wasn't built in automatically. I had to
Oh,
choose to
it's-
take certain electives
Okay.
to do so. It's just,
That's
the
fair.
framework is there for it.
But anyways, that's something to ask your advisor when you're here on campus, is to look into minors. Minors are 15 credits usually. Rather than a whole second degree, and then you can use those 15 credits as technical elective credit for part of them. And you can get sort of an additional certification that you have some studies in this particular area, like electrical engineering, mechanical engineering, or something else.
I would say if you want to double major, like you're going into college knowing what you want to double major in, think about where you want to be in a career first and then decide it that way. If you want to go into nuclear medicine and go into like, I can't even remember what my advisor did for medical physicist.
Yeah.
The guys who help run and plan cancer treatments and do quality assurance on the machines. Then you could look and do a nuclear major and double major in physics. A popular one that is really, really specialized, but Dr. Newkirk might correct me on this, that might be highly sought after is a double major in nuclear and materials engineering. You'll learn if, as you come here, that materials engineering is basically the backbone of all other engineering. Nothing else we could do would be possible without material engineers figuring it out first. So if you're specialized in materials engineering and you know radiation, the national labs are going to be knocking on your door asking for a job or asking if you will take their job. They will pay you lots of money.
So I hope that answers your question.
Let's see. So the next question we have is from Aiden asking, what sorts of work study opportunities could nuclear engineering students find at Missouri S&T?
So work study is generally run through FAFSA. So people are offered a work study. I myself am a work study at the nuclear reactor. That's what I started at before I got my operator's license. So I got to help do some basic maintenance, some like cleaning, a lot of paperwork filing, and just a lot of exposure at the nuclear reactor. But there's also working in the secretary's office here, specifically in the department. I had friends who worked there, just get to see the background of the nuclear engineering side.
Those are the 2 work study jobs that we typically have, one in the reactor every year and one in the front office every year.
Now, there's other ways of working on campus,
Yes.
and that includes undergraduate research.
Yes.
We're hiring somebody to work in the department just to help out with things around the department.
And if you
That's
have your,
not work study, which is a different program.
yeah.
It's direct pay from us.
if you have your reactor operator's license, we actually do pay a couple of students to operate our reactor. Who have licenses. So we have 2 senior reactor operators this year, as well as a couple of reactor operators who are students, and they actually are employed at the reactor. They work there and operate for our classes and for research and things like that.
For undergraduate research, if you know you want to go into research and development kind of things. The department may not have anything specific, but when you're here, ask your professors. Some of them might have some extra funding to hire a couple of undergrads to help out with research. For about a year and a half, I had a couple of undergrads help me with my research. Unfortunately, that was also when COVID hit, so we didn't really get a ton of stuff done for them, but I've had a couple of colleagues and friends who have had undergraduate researchers who have helped them basically with data collection and sample processing. And then they get, not only do they get to get that research experience and then they can get paid for it. Their names get put in, I believe, as authors on the paper that came out of it, which if you're going into research is massive. Going to any graduate school with your name on a published research paper is a shoo-in almost. You're gonna be sought after.
And some of the companies that have funded my research, the students got to interact with those people, and then they went on to work for those companies. So they got to experience what industrial research is like, and research on campus involved with grad students and the faculty, and they get paid for it, which is almost like cheating.
All right, thank you so much. We have a question from Lauren. She asked, do some students end up studying cosmic radiation with a nuclear engineering degree?
Probably not directly, but if you're talking about things such as space travel, where people are exposed to cosmic radiation, then yes, nuclear engineering would be teaching you about shielding, would be teaching you about monitoring, would be teaching you about health effects on.
I have some friends in the physics department who are more involved in the cosmic side of things.
Yeah.
And they really wish that they'd taken our interactions with radiation classes so that they understood them better, so that they would have had access into the nerd side of things more, but nuclear engineering in and of itself, no, unless somebody decided to do either nuclear engineering, then doing a physics type master's degree, or vice versa. So some kind of specialized studying researcher would have to take to go onto that path, I think.
Yeah, cosmic radiation, I would say, is more reserved for like a physicist.
Yeah.
But if you want to work with cosmic radiation, a nuclear engineering degree can be fine. I've got a friend up in Canada who works with their space agency, and they do some joint work with NASA. And he talks about how he has to interact with people like me who know in nuclear engineering stuff. And part of his job is translating what we tell him to the other people who aren't engineer minded. And there's a lot of material dosage involved, problems with electronics stuff, and basically EM shielding and radiation shielding for macro
So
electronics.
basically, studying cosmic radiation is what we would call science. And engineering by its name means you're using science to do something. So that's why I put it in terms of, protection against cosmic. Now that's engineering as opposed to studying the stars, which is more of astronomy actually, or physics, as you said.
Yeah.
So yes, it gives you the background to understand a lot about it, but your career will probably go in another direction, but it's not excluded.
We've had a number of students go on to do like a master's degree in physics, and because they wanted to get into things that were more like that. And a lot of those research type activities are going to require at least a master's degree anyway.
All right, I hope that answered your question. Let's see, the next one we have is from Quinn. Can you talk more about, there's a couple questions, but the first one is, can you talk more about careers and as far as what you plan to do with your majors after graduation?
I guess I'll go first because I can read the full question right now. So what are you all planning to do with your majors after graduation, and why are we getting grad degrees? So I'm getting a PhD simply because the work that I want to be involved in and what I want to do with my life kind of requires it of me. I would like to be involved in research and development on the cutting edge of nuclear technology. Let's just improve the technology and get it to a point where it can be easily incorporated into our lives, whether that's better fuel sources for reactors to provide better energy, that's nuclear medicine to improve techniques for cancer diagnosis or treatment, or maybe getting it, actually, I would really love to get involved in the fusion energy. Fusion energy to me is why I actually started my PhD, but that expectation was quickly tempered with, unfortunately, fusion is an incredibly complex problem, and we've been working on it for a long time. But the NIF experiment that just happened was pretty good. So that's kind of why I'm doing it. I just want to be involved. I like the idea of developing a new technology, introducing it to the world, and it being of benefit. But that's kind of why I'm getting a PhD.
Would you say you're going to the national lab rep then?
Yeah, national, sorry, yeah. So, I plan to go into the national labs. The national labs being like Argonne National Lab. There's a whole system throughout the nation. They do joint work with each other. They do their own work. They're pretty much everywhere. The ones I'm looking at specifically are Idaho National Lab, Los Alamos, Lawrence Livermore, and then Brookhaven National Labs. They all do a little bit of work that I'm interested in doing, and it kind of coincides with the research I'm doing. So it kind of works out that way. I've also have a bunch of friends and colleagues who've gone to the national lab system and they enjoy it.
All right, so me personally, as a senior sitting here now, I never originally intended to pursue a master's degree. So there's, I would say, about 6 or 7 general topics a nuclear engineer tends to go and do and pursue in a career. So number one, very like general, when you think nuclear engineer, you think of a reactor operator, somebody who works at a nuclear power plant. I pretty quickly realized that that wasn't something I was passionate about. Then there is like research, high level research, national lab, academia, even I would lump into those two things together. Generally, you need at least a master's to go work into research at the very least, but most often they recommend PhD. Same thing with academia, if you ever want to become a professor or something like that. So then as I started getting my classes, I realized there's a lot to nuclear engineering design. There's a lot of computer work, there's simulation and modeling and conceptual things. And so that generally leads you into a career of reactor design, even futuristic like design. But that could also, there's like 2 schools of design. There's design fuel for like current reactors, core loading, work for some kind of contractor that does things for a power plant, or there's design future things, small modular reactors, different types of materials. There's a bunch of nuclear startup companies doing some really cool design things there with gas cooled reactors, molten salt, just really neat things. But then I realized I don't like computers that much. So then that brings us to our 5th thing of, let's see, I usually have like a really good list of how I explain this. There's fusion, which was really interesting, but I just know that my technical skills just aren't quite up to par with that. And then I hit a class that I really started enjoying, and from running experiments and things like that, I realized I really am interested in materials. So I'm very much here at Kid with Dr. Newkirk. So I decided after an internship I actually had in a totally wild portion of nuclear engineering, it's a pretty niche area that I like working with people. I like the idea of strategic development. So I had an internship with a company called General Atomics, which most people might know generally as a defense contractor, but they started as a nuclear engineering company. So I found out that I really like pushing the next step of nuclear, being the person side of projects that Jordan might work on, being able to get international, like other countries to work together toward design steps and collaborative things like that. But I'm also interested in materials. So the next big steps is, especially in space, being able to get us to doing anything really neat, being able to apply nuclear energy to. We need to understand how radiation damages things, new materials, how they interact in different environments. So after working with our professor, Dr. Graham, who does a lot of our materials research, I decided that I want to pursue my master's with him, which in the company that I did my internship in directly leads me into more of their work. And they were very excited for me to do that. So they're kind of encouraging me, almost like guaranteeing a future job for me to do that. But I'm also still going about it in a strange route. So my funding for my master's degree is coming from something called the International Atomic Energy Agency. I won a fellowship with them. So after I complete my master's degree, I'm going to spend up to a year in Vienna working with them. They're mostly focused toward non-proliferation, which means stopping the spread of nuclear weapons, ensuring safe, peaceful uses of nuclear technology. So that is the most broad thing that you can do, because nuclear can be used for so many amazing things like medicine. That was the last thing. I found out I don't like really medicine that much. It was just, that was the last thing. That was number 6. So I, through a lot of trial and error, just kind of figured out, I still like what I'm learning about. I just need to figure out what I like applying it to. Because there's a million and one things you can do with nuclear. Sorry, Chelsea.
Oh, that's Kelsey.
I would say, right now, and as nuclear, as you go through, I promise you, you'll change your mind about what you want to go into every year, because you'll discover something new. Right now, what I'm interested in is the health side of things. So I had a medical emergency over the summer and ended up having to have imaging done that was using technetium 99. So shout out, knew that was for my classes. And it was the only way that they could diagnose me with my condition and get it treated.
Do you know where they made it?
And not a curium, I was
Did they
devastated.
make it myrrh?
Myrrh, was it?
Myrrh?
MERV provides 85% of the world's supply of technetium 99. MERV is the reactor up in Columbia at Missouri.
But I think seeing the personal effect of that, because I've never been diagnosed and I would still be in pain without that. So wanting to be in that realm is kind of what I'm thinking with health physics. And there is a lot of opportunities with that. You wouldn't think about medical. Someone who doesn't know that world exists, but there's a lot of opportunities and you don't necessarily need a master's or a PhD to do that. A lot of the companies that want people want just straight out of college.
Kelsey, Dr. Usman is attempting to start a master's degree in health physics,
Oh,
specifically to
Yes.
feed a lot of our students go into it
Yeah.
and wish they had more coursework. So we're trying to fill that gap.
S&T in the past has had an issue with mostly being focused on reactor design. And there is a big push within the student body and with the department head to fix that. So there is a lot more opportunities for health and medical physics in the department now.
All right, so what can I say on this? So I've had 4 internships at this point with 3 different companies. And yeah, I'm old. And so I've done, my first one was in industry. I went to nuclear engineering thinking I want to work at a nuclear power plant, I'll do all the innovation there. It'll be great. Everything will be, rainbows and butterflies. And then I got my internship in industry and I wasn't very satisfied with the amount of innovation that was going on. That was when people told me, what are you doing? If you want innovation, go to the national labs and do research. And so after I worked in industry, I got an internship with Idaho National Labs. And I love the work they were doing there. The group just necessarily wasn't the best fit for me. So the year after that, I got an internship with Los Alamos National Labs. And I've loved the group. I love the work I'm doing. And so that's kind of how I moved out of industry and looked towards more going into grad school and getting my grad degree. So I guess what am I planning to do? Planning to go into research, most likely at Los Alamos after I graduate. And then why I was doing the degree is because I wanted to do more innovation and everything. And that's really what happens at the national labs, which has already been mentioned before. They normally require master's or PhD. And then I'll also say it was more also a lot of me going down the path of least resistance. So here at our school, we have a 4+1 program. It's awesome. You save so much money on credits because you can like dual count them for both your undergrad and grad. So you save a buttload of money, you save a whole year of school. It's just like such a great opportunity. I recommend it to everyone who's here. If you're doing your undergrad here, get your master's in a year and save a lot of money. And now you have a master's, so you can go and get a higher starting salary when you go into industry. Or if you want to go into research, you got your master's in a year, you're way ahead of the game compared to other people.
That's basically what I'm doing, getting my master's to go into industry.
Actually, since we kind of brought that up, to talk about the third part of the question here, like, why are we getting the graduate degrees? Usually it's because the careers we want to do ask it of us. Like I wouldn't get a PhD if the national lab would hire me as a staff scientist on a bachelor's. But they asked me to have a PhD, so that's kind of what I do. If you wanted to be a medical physicist, very high paying career, very high skill set, they want you to have the education and the experience to back it up. So yeah, you can find jobs in these fields like we've had some of my friends and colleagues have gone to the national labs as bachelors. They work in the reactors up there or as a tech. You can go in there as a master's and you might be doing some research, but you're really guided by a guy with a PhD. So there's a little bit of everything, and usually I would say the question you should ask yourself before deciding to go to grad school is, do I need to? Like, does the career I want to do think I need that? And Dr. Schlegel might have a counterpoint here, but just in my experience,
They're
kind
high
of
school
helps.
seniors.
Huh?
They're high school seniors. That decision is 4 years out.
Oh, yeah,
It will be
it's
forever.
a long ways away, but like, I really didn't think I was going into grad school until my senior year of college, so.
Right, that's, I got involved in undergraduate research as a junior, so it wasn't until my senior year of college that I even thought grad school was an option.
Right, I guess the
So,
point.
and now I teach.
Yeah, I guess the point I'm trying to make is graduate school will probably be something you fall into, less so than seek out, unless you already know this day, you're like, I want to be a medical physicist at WashU.
I will say this though, as a nuclear, you have the opportunity to do your 4 years, say I didn't like school, I don't want to go to grad school, and you can get an industry.
Yeah.
With other degrees,
Yeah.
that's not an option. If you want a chem degree, you're almost definitely gonna have to do grad school when you did a PhD. There are opportunities at the end of your 4 years to get into the industry and make a buttload of money, so.
The students here are all leaders, and I'm gonna tell you that a lot of times, if you want a leadership position in innovation technology, the graduate degree is the ticket to that. There are wonderful careers that don't require it, but if you want to do more, if you want to be the person, the innovator, if you want to really make a difference in strategic studies,
And
a lot of times the grad degree is going to help you along that way significantly. By the way, I'm going to counter Eli slightly in that not all industry is non-innovative. There are a lot of today.
the nuclear power industry is not. They are focused on keeping the existing reactors doing their jobs to the best of their ability rather than figuring out new ways.
There's many companies, well, General Atomics
Yes.
is one, but there's many companies that are developing all
No.
sorts of new technology for them,
No.
including the
New scale nuclear reactor.
companies like
Excel. Yeah, there's a lot of companies that are doing innovation in nuclear power and things like that, just not the nuclear utilities.
They're doing their best.
I do want to add in here real quick at the end, that I have not once regretted what I've done with my graduate degree. I've had some low moments where I'm like, man, this really sucks, actually, like, I can't do it, I'm too dumb. But in the end, this is probably some of the most fun I've had with my academic career, and it's a huge accomplishment and milestone. If you ask me now, I would say I wouldn't regret any of it, I'd do it all over again.
I want to say one more thing, so sorry, Dr. Schlegel.
Okay.
So like what Dr. Newkirk was saying is. We're tend to be high achievers here sitting here. That's why we're coming to talk to you to get you excited about possibly going into this. The majority of my graduating class is going straight into industry once they're graduating. I know maybe 4 of the 28 of us are thinking into like going into this higher stuff. So I don't want you to think that it's intimidating, that it's almost a prerequisite to do anything. Like the majority of the people in my classes are looking to go work immediately, like, and they're excited to do it. They're
And-
excited to get into industry.
They're going into things like nuclear power, health physics. We have a few students who have gone on to work as health physicists at various companies. Several have gone to work at Curium Pharmaceuticals up in St. Louis. You know, there's quite a lot of options. We kind of focused on some of the stuff that we're doing, but there's a lot of opportunities for different kinds of careers aside from just, you know, nuclear power and research. I did want to kind of skip ahead, since we were talking about why they're getting graduate degrees. If we can come back to Leonard's question in a minute, because Calvin had a question about graduate degrees as well. While we're on the topic.
I think he's asking you, Donna.
Yes, so Leonard, I think you touched a little bit on, is there any research in fusion power?
Yeah, I think what Dr. Schlegel is asking, is it okay
Can
if we
we
circle back to that?
circle back to that because Calvin asked another question about graduate degrees.
Of course, what graduate degrees do nuclear engineers most often go into?
Well, I think the number one is nuclear engineering.
Yeah.
Material science is a very common one, or materials engineering, or metallurgical engineering, whatever the school calls it, there's different names for it. We've had a couple of students do like physics, engineering management has been one.
I would kind of say it depends if you're going in for a master's or a PhD.
Yeah,
Because if you're going in for a master's, then you would probably say, I'm going to get my master's in physics, or I'm going to get my master's in materials. Because the master's is very different, I would say, from the PhD. They're both graduate degrees, but the master's is you're kind of just getting those extra couple of years of specialized learning in to say that you are a master of this subject. And so if that's where you want to end your career, you basically end your academic career with a nice little bow that says metallurgical engineering or materials engineering on it. And from there, that's kind of like the end of your journey. With a PhD, it's more free form because you can have, depending on who your advisor is and funding available, all the other questions aside.
Yeah.
You basically pick or find someone to work with you on an idea that you have, or maybe you really like the idea this person has and you work with them. And despite what your research is, it just gets called a PhD in nuclear engineering.
PhDs do tend to be what we call interdisciplinary. They tend to cover more than one particular engineering focus.
Andrew, I cannot remember his last name.
See, I can picture his face, but I can't
Yeah.
believe it.
Liebman?
No, not Liebman.
He didn't do masters.
From materials, he worked with Dr. Wen.
Yes,
Yeah, I can't remember
I
his
can
last
picture his face. I
Yeah,
can't remember
we,
his name.
you know, I had a colleague and friend who, he did a nuclear undergrad and then did his materials PhD here at S&T. But all of his stuff was about radiation environments.
Yeah.
That PhD can be done in either department. It's basically just saying on the certificate he gets when he's done, whether it's a PhD in materials engineering or a PhD in nuclear engineering. Effectively, it's the same research. The thing about PhDs really is what kind of publications you're going to get out, and then just the nature of the research itself. Whatever category you place it under is pretty tertiary to everything else, I would say.
Honestly, the master's program is pretty similar though. So if I was here for another year, I probably would have pursued a master's in material sciences instead of just sticking with my nuclear. Because I'm only here for a year, I don't have the opportunity to take classes in as many classes in the other department. So, but the way it kind of works is it's just kind of these blank slots of I can take any like courses that would attribute like to the specific like degree level, as long as I plan it out with my advisor. So I'm taking a advanced scientific Russian course, and that's counting toward my nuclear engineering master's. So you can kind of double dip in a few different departments, and it is really just like the name, even for the master's.
I guess we should put a disclaimer that this is department dependent.
Yeah.
Some departments might say, oh, you're doing a master's in this, you have to take these courses.
Our department is pretty flexible.
Yeah. But PhDs are pretty free form. You pick and choose classes based on interest to your research, and you work with your advisor on it. And, you know, if I wanted to do it, I did a graduate class from biology about grant writing, and that was fine by my advisor, so he okayed it.
Writing grants is important
For PhDs.
for PhDs. Okay, then we can kind of circle back and get back to Leonard's question.
All right, I'm excited for this question.
All right. So research in fusion power. Tell us all about it.
So there is research in fusion power. There's not a lot going on here at S&T. It's not been one of our focus areas. But there is a lot of research going on at the national lab level and at some other universities. There was a big announcement recently, and I'll let Jordan tell you about it because he's chomping at the bit here.
Well, I'm letting Dr. Schlegel also get the temper your expectations about fusion at S&T first.
That's an opinion, so I'll just leave it out there.
All right, so there is research in fusion, like Dr. Schlegel mentioned. Specifically, the nature of fusion as a problem for us understanding that technology is not something I don't think any one group is gonna figure out. Like if you look around, you'll find a bunch of private industry and private companies that are saying that they figured out how to do fusion, and they're kind of correct. They figure out the next stepping stone that everyone else uses to go to fusion. So I think we've talked about this before, Dr. Schlegel, where it's either going to be actually some mad scientist in his garage that solved it, somehow flying under the radar of every agency on the planet, or it's going to be a decade-long expeditionary effort from major nations. So the NIF test was a big one. That was the first time experimentally we have shown that we got more energy out of a fusion reaction than energy input. There's a whole bunch of scientific terms in there that I can go over, but basically that's what it comes down to is they used lasers that had a certain amount of energy, got fusion reactions, and those reactions produced more energy than the input energy, which is absolutely huge as a milestone for fusion. but actually getting electricity out of that and, solving the energy crisis, as one could say, very, very far out. We're looking at maybe at another 10
There's a major materials issue.
Yeah.
When you get fusion operating.
currently,
And
the first
I've
wall
got
was a problem.
40 years of experience. I did nuclear fusion materials 40
The
years
other
ago.
issue
Still
is
do.
that they broke even if you only count the energy of the lasers
Yeah,
that was input to the fuel pellet, but if you have to look at the energy input to the lasers to create the lasers, they're still on.
oh yeah, no,
it's stuff.
it's a very,
It's a long-term challenge. It's gonna take a lot of really smart people working for a long
A
time
lot of government.
on a lot of different problems. There's a lot of things that have to be addressed before fusion is something that we can use to generate electricity.
so like Lawrence Livermore was the lab,
Yeah.
it structured the experiment and did the experiment at the National Ignition Facility. But you also have the ITER project going on in southern France, which is a massive multinational effort. They plan, I think it was 2030 now, 2025.
Something like
They,
that.
they plan to achieve ignition within, I think, the next decade, which ITER is, I think, most people's expectation for like a massive milestone achievement. But like Dr. Newkirk mentioned, we have the first wall problem. Fusion is incredibly radioactive with neutrons, and neutrons are the most damaging form of radiation just because of how they are. You can't control them, they exist, and they take your lifespan of a reactor from 40 years down to like 10 years because of how damaging and plentiful they are in a fusion reactor. And then you have to worry about, okay, now we've solved that, how do we now get energy out of this to produce electricity? I think current expectations are we're gonna boil hot water and make some steam.
Helium.
my favorite.
Oh, they're gonna do gas transfer?
So Monica's working on that. So they're
Okay.
using helium cooling in the first wall.
From some
Okay.
interesting industry experience, so General Atomics is a pretty unique company because they run the D3D National Fusion one of the National Fusion experiment facilities. So they're constantly running hundreds of shots a day on an experiment day of figuring out if they can contain a plasma. They do research there, they host international researchers and do training. I got to sit in on a lot of international business calls because I was doing work in both fusion collaboration and fast gas reactor collaboration type things. So I got to hear a lot of interesting work that Japan and India are doing in this. And so fusion is such a really cool research place because everybody shares so much work. So I was sitting and listening about like, oh, well, we can give you this component that we've made new if you can train our students to work at this facility and take these measurements. And General Atomics, I got to tour this facility where they're actually building the center solenoids for the ITER facility. So that's an incredibly interesting materials project. They dropped like a screwdriver in the middle of one that they were running an electrical test and it was floating in there. And I was like, I didn't realize how much materials was going into this. So there's a lot of there's also industry that is participating in this research.
Now, in March, the Loffer Symposium, there'll be several fusion companies who are attending and they're wanting to do more research with us. So we've been expanding that. The closer fusion gets to practicality, the more kinds of things we can do. But it takes a lot of money and a lot of equipment to study fusion. How many lasers were there at Lawrence Livermore firing at one time?
They had what?
It's 193.
Yeah,
193.
Almost 200 lasers aimed at one spot.
Yeah, to cover 360-degree angles and.
That takes huge amounts of government funds.
Last fun fact, General Atomics produces the targets that are used in those experiments. So I got to see the production of these targets and the engineers who are designing them that are helping fusion research.
To add on to what Dr. Newkirk was saying is. Dr. Elijah likes to talk about this a lot. I know he's not here right now and I keep referencing him, but basically. You guys as incoming students to a nuclear program have this opportunity to. Go through your education, pick up some different knowledge about like fusion energy, and then by the time you guys graduate, there's probably gonna be more opportunity available that's in demand than right now.
Yeah.
Now I know in the press release from Lawrence Livermore, they were like, this is really cool, this is awesome, we're hiring, please come work for us.
Yeah.
And so like, if they're hiring in demand now, think about where it's gonna be in 5 years, as the technology gets further and further.
Talent acquisition is always a challenge, and it's been a challenge in nuclear engineering for a long time. There are a lot of companies that are facing waves of retirement and they need to hire new people. The national labs are facing waves of retirement and they need to hire new people. And then the background of that is with COVID and everything else that's been going on, hiring in general is difficult right now. There's a sort of a shortage of talent, so there's a lot of opportunities for talented individuals to get their education and go out and make their mark on the world. I think our placement rate is something like 97 or 98%.
What's a placement rate actually?
Number of students who get jobs within 6 months after their graduation date, including graduate school as a job.
In fact, many of them get the job before they graduate.
Yes.
I mean, I'm a junior and I have 2 job offers when I graduate. Like, if you get involved in the clubs and you talk to the different recruiters, and you make a relationship, you will get offers. Like,
Networking is the name of the game.
yeah, it's not a dying industry. Yeah, like, that's what my whole family told me when I went to nuclear. Like, you're stupid. Like, they're shutting down all these reactors. Like, you're not gonna get a job. You will get a job. I promise. If you put the work in, you will get a job.
Nationwide, only about 500 nuclear engineers graduate every year. And probably a third of those end up going to graduate school rather than out into the working world. So there's a lot of demand for those 360 or so other graduates.
To add on to that last part about getting job offers as an undergrad, the A&S stuff, absolutely valuable. I wasn't super involved with A&S as my undergrad, but
American Nuclear Society Club.
sorry, I'm used to the acronyms. But what I'm getting at is start with your freshman year. If you like nuclear engineering, you know you're coming here, get involved with the American Nuclear Society student chapter here as quick as you can. And
Also,
then, yeah, also
Women in
Women in nuclear.
sorry, I'm thinking specifically about the student conference that shows up in February, March, because the sooner you go to those conferences and start making friends and connections, those recruiters at those events usually are the same people. So they'll remember you year after year and they go, and especially if you go and like, you get to be a presenter. Some freshmen, if they get lucky enough, I guess, or they put the work in, they can be asked to present something, whether it's just a poster or a talk. But that puts a name to a face, and these people remember you. They go, oh yeah, you presented that last year. And then some people maintain friendships and all that throughout their college and from other universities.
We had a lot of fun. We played volleyballs and it's not just a professional society, it's a department family.
You guys went on a float trip last year?
Yeah.
I was gonna try to go along, but I had Cub Scouts
This year,
with
this
my
year.
kids, so.
We'll get you
Yeah.
on a boat this year.
All right.
too.
We're
All
very
right.
short on time.
Yeah, we
Yeah.
have another question, I think.
Yes, the last question of the evening is from Tyler. He's asking, what other certificates can you get while at S&T?
Non-proliferation in our.
Yes, in our department, we have a graduate certificate in non-proliferation, which is roughly half the number of courses that you would require to get a full master's degree. And then if you do get the certificate, you can come back and get credit for those courses if you decide to continue and do a master's degree at a later date. There are a number of those kinds of certificates that are available throughout the university right now. Typically, they're 5 classes or 4 classes?
4 classes is the standard, 4 3-hour classes, so there's materials, there's ones in manufacturing, mechanical.
Big piece of
explosives.
advice for 2 minutes left, look up MST 8-semester plans. That leads you to every single department's advised course of study. It shows every minor that could be available, master's degree and certificate programs. That was one of the first things I looked at. It was really hard for me to find when I was a freshman. I just wanted to throw that out there. Every certificate's listed.
That's a great.
And we add new certificates every year, about 5 a year, so.
So
it
MST
changes.
8-semester plans.
And then if you're, some of this, so there are some things that are not necessarily like full-on certificates, but engineering management has classes where you can get certified in 6 Sigma, which is a sort of quality control, engineering problem solving methodology that there's a lot of companies looking for. So you could put that on your resume if you did that as well. So there's some other other things like that. We already talked about the reactor operator licensing, so that's a certification that you can get.
That's a big one.
Yeah, that's the license doesn't carry with you. You can't go to a power plant and say, I've already got a license. But the content is very similar, so it helps show that you really have what it takes and you know what's expected in order to make something like that happen.
From the employer perspective, if you go to, like, if you want to go work for Callaway up in near Columbia, Missouri. And you have that license from our reactor on your resume, they're gonna look for you first, because you've already proven that you can take the NRC licensing exam and pass it. They're not gonna take a risk on someone who doesn't have that when they, oh, this person's already got it. Well, we'll bring them in, train them up, they'll pass it, and we're good. So it's a big resume tool. And not to mention all the experience you get with that. It's helpful as your undergrad studies too.
And before we leave, I'll just mention, if you do have some questions and you'd like to ask us, nuclear@mst.edu is the department email address. So if you send emails that direction, make it to Dr. Newkirk or myself, or we can have forwarded to one of the students. So you can continue to ask us questions and get in touch with us after tonight.
Well, thank you, guys.
Yes, thank you so much. It's 8 o'clock, so that is the end of our presentation. Again, I will be sending out a copy of this recording to all the attendees. So if you need to revisit anything or ask us any questions, I will include contact information in my email, and we hope to see you in fall 2023. Good night.
Good night.
Bye all.
Good night. Thank you so much.
Gotcha.
Good night.